Hi, I gave you this question. What is the probability more than 37,000 miles? Uh, as in the as like the previous question, you have to follow these three steps. First, standardize x and the value. Like particularly, we are interested in this value, 37,000 minus 35,000 divided by 5,000 is the standardization. And this value, the standardization equals to zero point 0.4. So zero point 0.4 standard deviation above its mean. And as I said, this probability is correctly, it's about standard normal distribution, but this is not a CDF of a standard normal distribution. So you need another transformation in this step. So probability greater than zero point 0.4 must be transformed into 1 minus probability smaller than zero point 0.4 because Excel only tells you this probability smaller than something. So probability greater than something does not exist in Excel. And then finally, you have in step 3, find this probability. Probability smaller than zero point 0.4 can be found from a program or calculator or a table, and then it equals the probability smaller than zero point 0.4 equals to 65.542. So subtract this from 100%. That's the probability we wanted. So about 34% of tires last more than 37,000 miles, right? So again, we use standardization method and the CDF of a standard normal distribution. Finally, the third type of probability is a probability in between 2 points. If you are smart, then you will get it like now. Without watching this, you know how to do this. But let's see that. Let's like do it step by step. So always the first step is standardization. X is non-standard. So standardize X into Z. And here, remember, you have to standardize all the accompanying terms because you have two inequalities. You have to make their level like comparable with each other, right? If you standardize only one of them, like if you standardize 30,000, its standardization is -1. But if you don't standardize the other side, it may remain as like 40,000. So you see the difference in the unit. So to make the unit consistent, you have to standardize every term, every part of the inequality, right? In the end, the probability is in between, the standardization is -1 and +1, right? We use the same numbers, and we have seen the standardizations before. So -1 and 1. So we are looking for probability between -1 and 1 for the standard normal distribution. However, again, this is not a cumulative probability. It is not a cumulative probability, so we have to convert the probability in between 2 points as into the difference of two cumulative probabilities. So remember, probability between -1 and 1 equals probability smaller than 1 minus probability smaller than -1. And then these two probabilities can be found from the table or Excel, right? So the first probability is 84 something, and the latter probability is 15 something. And do the math. if you subtract them, you get 68.269%. So in between -1 and 1, there is about 68%, right? This is exactly what we wanted. And do the same similar question with different numbers. Then what is the probability between 32,000 and 37,000 miles? Try this. And I want to give you a chance to exercise and just repeat what I have done and see what you if you can do this. And pause the video now and try it. I'm going to proceed. 1, 2, 3. So standardize. 32,000 becomes minus zero point 0.6. 37,000 becomes zero point 0.4. We have used these two numbers too before. So we have, so the probability we want equals probability between minus zero point 0.6 and zero point 0.4. And the probability between these 2 points is the difference of these two cumulative probabilities. Probability smaller than 0.4 minus smaller than 0.6. And then find 0.4 from the table and minus 0.6 from the table, or Excel, I mean. So then, as a result, you will have 38.117%. So, a summary. If X is a normal distribution with non-standard parameters, you don't need to worry. Probability smaller than something can be found from the standard normal distribution. Probability greater than something also can be found from the CDF of the standard normal distribution. Probability between 2 points, of course, can be derived, can be obtained using the CDF of the standard normal distribution. Right? Okay. The last topic we want to study is this. For example, in the same example, suppose that you want to say you are advertising the tires and you want to say 90% of your tires last longer than blah blah miles. How many miles can you say here? And this number that goes into this blank will satisfy this. Not the probability that a tire lasts more than A miles equals 90%. This is what exactly this sentence means. 90% of tires last longer than A miles. Then what do we do? Anyhow, as you see, the structure of the question is a little bit different. In our previous slides, we knew what A is. This value was given, but now A is what we need to find, but what's given is the probability 90%. So in the previous slides, we are given A, and then we have to find probability, but now it goes the other way. 90% is given and A is what we are looking for. Then we have to go through these 3 steps. First, standardize this probability. But the problem here is you are going to standardize A, but you cannot calculate the number because A is unknown. A is unknown at this point, but still you have to standardize. But what you are doing is, in the second step, we use the standard normal distribution that satisfies the same form using 90%. So find B, the value B, that satisfies the same structure probability equation with Z, the standard normal distribution. And then finally, we are going to match these two equations and obtain A. Let's see the details. Step 1, standardize the probability about X. So our probability is about X. Standardize then you have A minus 35,000 divided by 5,000. This is it. You cannot do any further than this because A is unknown, or there is nothing to calculate. You cannot do anything. So this is the standardization of A, and as our clue, this is our clue. So we just standardized the left-hand side. So the standardization process does not change the probability itself. So after the standardization, the probability must be 90% as before. So probability x greater than A equals probability z greater than this standardization of A, which uh, is by assumption by the question equals to 90%. And then so this is the step 1. And step 2, just find the value that enters here. So this is the unknown part, and you have to find this part from the standard normal distribution information using, like here in this case, its top 90% value, which is minus 1.28. And then in the third step, these two are the same structure, so you have to match these two. The standardization equals to minus 1.28, which means this. So if you solve this equation for A, you will have this, and the end will be 28,600 miles, right? So the main idea is the same. You have to standardize, and then you have to use standard normal distribution table or Excel in the second step or the last step. So, and now in this example, you have to do these two steps separately. Standardize, and then standardize using the left hand side, and using the right hand side probability, find the corresponding value. Then match two values at the end. Okay, then the last question of this slide is, so I gave you the values for top certain percentage values from standard normal distribution. Using this, by the way, these 5 numbers are usual suspects. You are going to see them a lot in the following slides. And we would like to say something like this: 95% of tires cannot last up to this miles. What is the number for this blank? Which number do you think is appropriate for this blank? Pause the video, and this is the last question, and try your best, and I'm going to proceed. 1, 2, and 3. So to summarize the sentence, so 95% of tires cannot last A miles. So the life is smaller than A number of miles. And so this is the clue. We have this one equation. And first, step 1, the left-hand side probability must be standardized. And we have the same standardization. And in step 2, use 95%. Using the 95%, you have to find the corresponding number. Here, we know top 5% value is given by 1.64. So if you plug in 1.64, this equation will hold. Then finally, match this equation to this equation, right? So A minus the standardization of A equals to 1.64. Then it is easy to solve for A. A equals to 43,200 miles. This is how we utilize the standard normal distribution to calculate percentiles or top certain percentage values for non-standard normal distribution. To summarize, if you want to calculate A such that probability is smaller than A equals to P, where P is known, P is given, then standardize A into A minus mu over sigma, and then find the value B that satisfies the same probability for a standard normal distribution. Then match these two. Then in the end, it's easy. If you rearrange this, you get A equals to mu plus B times sigma. So that is the P percentile value for X. Okay, finally, we learned these guys. You have to be able to compute probabilities about standard normal distribution and percentiles and top probability alpha values. And then use that information and standardization method to compute the same guys for any non-standard normal distribution. So this is more about uh, preliminary exercise for the following chapters. We are going to use these skills many like a lot in the following slides. So you have to make yourself familiar with these methods. Okay, thank you for watching the video and see you in the next chapter.